Hello student, this is Rimpa Singha Roy and welcome back to your lesson. This is the part 3 of my lesson, and in the previous lessons we have learned about null relation, universal relation and equivalence relation. So now in this part we are going to find out that whether null and universal relation are equivalence relation or not. So without any further ado, let's start today's lesson. So here is the question, that is a null relation and equivalence relation. So first let's look at the definitions of an equivalence relation. An equivalence relation must be reflexive, symmetric and transitive. Now for a reflexive relation, all the identical elements of the domain set must belong to R. All the identical elements of the Cartesian product for every element of the domain set must belong to the relation to be called a reflexive relation. As null relation doesn't contain any element, so it's clear that it doesn't contain the identical elements. So it can't be a reflexive relation. Okay. Now for symmetric relation, if for any two elements A, B, then AB belongs to R, then BA belongs to R. That means if the particular relation contains point like AB, then we will check that whether it contains point like BA or not. As null relation doesn't contain any element, so it's actually satisfy the symmetric condition, or we can say it doesn't disagree the symmetric condition. So it is a symmetric relation. Okay. Now for transitive relation, it's actually the same with symmetric relation. It also doesn't contain any point like AB and BC, so you need not to find about AC. Okay, so it will also be transitive. As it doesn't fulfill the reflexivity conditions of reflexivity, so it will not an equivalence relation. So null relation is a symmetric and transitive relation, but not an equivalence relation and not a reflexive relation. Now the next question is universal relation and equivalence relation? So we will discuss this in the example. You have already seen this example before. He is John, his father, mother and brother. Okay, and F cross F is actually the universal relation on F. Now it contains FF, MM, JJ and BB. So universal relation is a reflexive relation. It's clear. Now if we talk about the symmetric and transitive relation, then it is an universal relation. So it contains all the elements of the Cartesian product. Okay. You won't find out any point in F cross F which dissatisfy the symmetricity or the transitivity of the relation. So it is symmetric and transitive as well. As it satisfies all these three conditions, so universal relation is an equivalence relation. It's a equivalence relation on the domain set. Okay, so that's it for the lesson. We will meet you in the next lesson. Thank you so much guys. Till then, keep learning, keep growing.